So before we start on that other stuff, let's look at this stuff right here. Others of you, this may be kind of useful. We'll see. All right. So let's look at some examples up in here. So our first example, this is decimals to percent. So let's start with the decimals such as, what do you guys want? Say 0.5. Okay. Well, some of you guys know what that is as a percent anyways, but this is what you would do, okay? You move the decimal 2 times to the right to make a percent. So we're going to fill in the blank with the 0, and then it becomes 50%. So what do we do with another example? Let's say we had 2 decimal places, such as 0.87. Sure. Well, same idea on these. We're going to move the decimal 2 times to the right, giving us 87%. All right, so let's look at that 0.008. Let's say 83, just to make it interesting on that. Well, again, we would move the decimal 2 times to the right. Now the decimal is in front of that 8, right? So that becomes 0.83%. Which means that this is, it's almost 1%, but it's less than 1. Yeah. All right, well, what about this one? Same idea. 2 times to the right, 1,046. You can put 0.0 if you want, percent. Bam. So yeah, as it turns out, you can't have percentages that are over 100. Someone said in one of the classes that their elementary teacher said not to do that, or that you can't. That is false. Elementary teachers do the best that they can, all right? But there are some situations where you can have over 100% of something. Okay. All right, now let's look at percents to decimals, because we just did decimals to percents. And hopefully it kind of makes sense what will happen on these. So percent such as 25%. Well, it doesn't show a decimal on this, but it does have one right here. And if we move decimals to percents, if we move the decimal to the right, then we're going to move these ones to the left. 1, 2, and that would give us 0.25. Now that's the decimal, so then we're good on that. Well, what if the decimal were to look something very different, or not the decimal, but the percent, something like 3.19%. Well, still, we're going to move that decimal to the left, 1, 2 spaces. Any empty spaces we'll fill in with zeros. So this is 0.0319. All right, one more example on the here. This time we'll try a very big number, such as 258.18. Okay. Well, on these, we're going to still move the decimal 2 times to the left, giving us 2.5818. There it is. All right, how do we take decimals and turn them into fractions? All right, now we're not going to worry about repeating decimals, thank goodness. You won't have to worry about that until 8th or 9th grade, which is good. So we're just looking at non-repeating decimals, which are terminating decimals, such as 0.125. Okay. So to change this into a fraction, what we do is we got to consider the place value of the number farthest to the right, 5. What place value is that 5? Tenths, hundredths, thousandths. That's our denominator. And then we just write that number, the 125, as the whole value, 125. Now, yes, we could simplify this, but this should help you get started with making this decimal a fraction. Okay. It does end up being 1/8. All right, this one. Once again, we're looking at the number farthest to the right, which is this 5. The place value of that 5 is hundredths on this one. And then the other number, this whole thing, we're just going to write as a regular non-decimal value, 835 hundredths.
Couldn't you just do 8?
No mixed numbers.
Oh, yeah.
All right, so once again, you know what, let's give this one more place value because we had another one to the hundredths. So we'll say that's 4 up in here. Well, once again, I'm going to look at this. The place value of the 4 is in tenths, hundredths, thousandths. So I got 1,000 in my denominator. Then I'm just going to write that whole number as a whole number. There we go. All right, well, what about fractions, the decimal, simplified or no? Let's look at a couple examples on these, and we'll see this as well in some of the other examples. But let's do one of these. Let's do, I don't know, not sevenths. Those are pretty big. Let's do 3/10. So this is 3/10 as a decimal. This would be pretty easy, but usually what we do is we acknowledge that the divide is the fraction line. So this is really just 3 divided by 10. Now we could use long division, which we will do eventually, but as a decimal this comes out to 0.3. So what do we do if we had something like 10/8? Well, again, 10 divided by 8, which would give us 1.25. Again, we'll look at this using long division later though, but it's just division, that's all it is. Alright, 7/9, again, this is 7 divided by 9er, which as decimal would be 0.7 repeat. On the calculators, it's going to show 0.7777778. That's because it's rounded that next 7 up to an 8. So just know if it shows that it's repeating, the calculator just can't show you anymore, so it's telling you that it can't show anymore, so it rounded. Alright, percents to fractions. These ones aren't too bad. So for example, if we took something like 40%, like these, all we're going to do is we're going to rewrite this as a fraction. Now percents, as it turns out, percent in America is one word, but in most countries it's 2 words. So percent, cent is hundredths, so that means that all denominators are hundreds. And then we just write the percent in the numerator, 40. 40 hundredths. Now, of course, you would simplify that, but right now we're not concerned with that. We'll do that later. All right, what other percent?
Wait. 99.
98%. That'll work. All right, 98%. Once again, we will write this because it's percent, so it's in the hundredths. And then we're just going to write that number, 98. 98 hundredths. There you go. Let's do one that has a decimal, though. Something like 4.72.
Sure.
Bam. Percent. So if we wanted this one as a fraction, again, it's out of hundreds. And then we just write that number, 4.72. All right, finally, fractions to percents. So this one is related to fractions to decimals. We just got to go one step further on that. So let's say that we had, I don't know, 8/12. Okay. So I would want to change this into a decimal first. So I would do 8 divided by 12, which would be 0.705. And then I change this to a decimal, percent rather, 1, 2 to the right, bam, 75%. So that's all we're doing is we're changing this fraction to a decimal and then the decimal to a percent. So it kind of has 2 conversions on that, which is good. All right, so once again, this would be 10 divided by 12. And as a decimal, all right, so this is our decimal. Then we would move the decimal 2 times to the right, 1, 2, which would give us 83.3 repeating in percent. So we're starting this stuff. We'll just be looking at changing some fractions into decimals and decimals to fractions, and we'll mix those up as well. And so for this first one, we got that bar, and it has been broken up into two parts. So one of those parts, that's that first one, it's one of these parts. Now the fraction would be 1 out of 2 parts for that. And the decimal for 1/2 would be 0.5. Now that's just a common decimal. We may or may not need to do the work. If we do need to do the work, we'll show that later, all right? And then the percent on that would be 50%. All right, the next one, 2 parts, includes both parts. So there'd be 2 out of the 2 pieces. So the decimal is 1 or 1.0, which means that it would be 100%. All right, now this bar has been broken up into 4 pieces. So one part would be 1 out of 4 pieces, and that decimal is 0.25, and the percent is 25%. Again, if you don't remember how to do these, we'll look at them later, but for now we'll just show them as is. So the next fraction would be 2 out of the 4 pieces, which is 0.5. You can put 0.50 if you want, because the percent is 50%. So 3 parts would be 3 out of 4 pieces, a fraction. The decimal, 0.75, and the percent, 75%. So with decimals, especially on tests, right? So here's what I may see, is your answer for decimal would be 0.75. And that's the 75, but when I see the decimal, I see this. Now, I don't know if you guys can see that mark. I can barely see it, even on the iPad right here. So, the problem with this is, well, it looks like 75, right? And I can't tell if that dot right there is a scratch or maybe your pencil grazed the paper. So, if you're not going to show the 0, emphasize the decimal. Actually, if you're going to show the 0 either, you'll still want to emphasize the decimal there, okay? Because if I can't see it, then I think you're trying to write something different. All right, now this bar has been split up into 1, 2, 3, 4, 5, 6, 10. Yeah, very good. So yeah, we got 10 pieces up in here. So 3 parts would be 3 parts out of the 10, which as a decimal is 0.3 or 0.30, which is 30%. So 8 pieces or 8 parts would be 8 out of the 10, which as a decimal is 0.80, which as a percent is 80%. And then finally this last one, how many parts we got? 1, 2, 3, 4, 5, 6, 7, 8 of those. So 2 parts would be 2 out of the 8, which as a decimal is 0.25. We've seen that one before. As a percent, 25%. So 7 parts would be 7 out of 8 as a fraction. The decimal, 0.875. Again, you don't have to know how to get that yet, but we will look into it. And that as a percent is 87.5%.
I know how to do
So the second one right account, it's been split up into 3 parts. So the fraction for 1 part would be 1 part out of 3. And the decimal there would be 0.3 repeatant. And then the percent would be 33.3 repeating percent. Now that's just for the percent. So let's look at 2 parts, which would be 2 out of 3 parts. So the decimal would be 0.6 repeat. So that'd be 66.6 repeat percent. All right, the next one, this one has been split up into 5 parts. So one of those 5 parts would give us a decimal of 0.2. And the percent would be, well, not 0, but 20%. So the 3 parts would be 3 out of 5 parts, which gives us a decimal of 0.6, which is also 60%. So the bar on the left is divided into 6 parts. So if we had 1 out of those 6 parts, then the decimal would be 0.16. I think that repeats. Let me check. Yeah, so just the 6 repeats on the these, which gives us 16.6 repeating in percentages. So if we had 2 of those, that would be 2 out of 6 parts, which is just like 1/3, so 0.3 repeat, which is, as we have seen already, 33.3 repeating in percents. So 4 parts would be 4 out of 6. The decimal there is the same as 2/3, so 0.6 repeat, which is also 66.6% repeat the 6. All right, this grid to the left is a 10 by 10 grid. Why do you think it's called a 10 by 10 grid? Yeah. Very good. 10 horizontal, 10 vertical, bam, gives us a 10 by 10 grid. So how many, I don't know, I guess they should be squares. How many squares are in the grid? There's 100 of them, right? So then we'll use the grid to show the fraction 6/100ths, and we'll explain why this model is correct. So there are 100 parts to this grid, because it's a 10 by 10. So we're going to fill this in. 6 of these. Well, there's 1, 2, 3, 4, 5, 6. 6 parts filled out. Now, I know some of you guys want to take this to the next level, right? Like, well, this is great. I know that I need to fill in 6 of these, so I'll fill in this one, and then this one, and then this one, and yeah, that's great. You got 6/100ths on that, but why? See what I'm saying on that? So just fill them in, kind of like we did before, right? 3 and 6. There we go. Try to keep some order on these. So why is this 6/100? Well, we got these 6 parts that we filled in, and there were 100 parts to begin with. So this would be 6/100ths. All right, well, what about this grid? What fraction is shown on it? And then what is the decimal equivalent? We'll look into that. All right, so we could look at this, and we could count each of these individually. But just to take a shortcut on this, we know that there's 10 in this row, then there's 10 in this row, and there's 10 in that row. So that accounts for 30, and then we got 1, 2, 3, 4, 5, 6. So we can see that there are 36 pieces shaded out of 100. Now this fraction, some of you know, can be simplified. That's okay, we're not so worried about that right now. But the decimal for this is easier in this form because we can see that this right count is hundredths. So in decimal place values, we got tenths and then hundredths. And how many of them do we have? Yeah, we got these 36 of them. So we'll just fill that in, 36. And this reads as 36 hundredths. All right, for number 7, we'll shade the given decimal in each grid below. We'll start with B on this. So this one is 0.35. Now again, it's important to realize the place values of these. 3 is in the tenths. 5 is in the hundredths. So as a fraction, this would be 35 hundredths, like these. Now, in this grid, it's a 10 by 10 grid. So we know that out of the 100, we need to fill in 35 of these. Now, the nice thing about these is I go ahead and fill in a row, like this one. And that would be 10 parts. But we need 30 of them. So I'll fill in all of these. Now that's only 30, but we needed 35 out of 100. So we got 1, 2, 3, 4, 5. Bam. This next one can be a little tricky because it looks like 4 out of 100. But again, we have to address its place value. 4 is in the 10th position, which means there's a 0 in the 100th position, making this as a fraction 40 hundredths, like these. So when filling this out, I need to fill out 40. Alright, so we've been filling them vertically, but you can do it horizontally if you really want to. Just don't scatter them, alright? So there's 10, right, on this row. And there's 10 more up in count. That's 20, 30, and 40. Bam. Yeah, no problem. For D, do this one in red. So again, and we got to look at the place values on this, right? So that's tenths, hundredths, and then 5 would be thousandths. Now really, we just need to look at the hundredths position right account, which means you'd have 12. But then you'd have also a half of a hundredth right there. Okay, now again, we'll look into that in a moment, but we want to look at this in terms of hundredths because this grid has 100 parts to it. Now we could split it up into 10 more parts, giving us 1,000 parts, and then fill out 125. That wouldn't be too bad, but just for the sake of comparing these with percentages, we want to compare these in hundredths, okay? So, for these, I'm going to fill out 12. So there's 10 right here. And then I've got 2 more right here. And then, yeah, for the half, I'm just going to specify right here that would be half a part. Now, yeah, that's a little bit darker, and it may not be exactly a half, but it's just to show that I can see that it's 12 parts and then a half part. All right, write the fraction equivalent for each decimal in number 7 in simplest form. Okay. So B was 35 100ths. Oops, something. Yeah, so that one can be simplified by dividing both of these by 5. Right? Both of these are divisible by 5. So this would change it to 7/20. Now, 7 is prime, so it can't be simplified any further because 20 does not go into 7 either. So the next one up was that 40 hundredths. And some of you guys know we can just slash out the 0 right there, which is kind of like dividing both of them by 10. So comparing 4/10 may be a little bit easier. Yeah, very good, because we would divide both these scale factors by 2. So yep, we end up with 2/5 on C. And then D, I'm going to compare the original fraction on this one, which would have been 125. And then the place value of that 5 was in the thousandths, like these. And as it turns out, both of these are divisible by 125. Now you may not have known that immediately. You may have divided by 5 and then divided by 5 and then divided by 5 again. But for the sake of time, we're going to simplify this a little bit faster to give us 1/8. Alright, so this one shows, this is a 10 by 10 grid, so there's 100 of these squares. And we can see that this row is shaded in, and so is the second row. So that's 2 rows of 10, which means that 20 are shaded out of the 100 squares. Now if we simplify these, which we can do, both these are divisible by 20. So this ends up being 1/5. Simplified. What is the decimal equivalent for this fraction? Well, we can use either 20 over 100 or 1 divided by 5. So if we do 1 divided by 5 in our calculator, we should get 0.2 decimal. Bam. So 0.27, if we change this into a fraction, this would be 27. And then the place value of the 7, hundredths. Bam. So this is good because our grid is already in hundredths. So all we need to do is shade this thing in. So how many of these would we shade in?
27.
27. So I got this row right here. Then I got this one right here. That's 20. Then I just need 7 more, right? So 1, 2, 3, 4, 5, 6, 7. There we go. Alright, yeah, so for part 8, we already had that fraction, 27 hundredths. Bam, nailed it. Shade the fractional part of each grid, then write the fraction as a decimal and a percent. Alright, so here's A and B. So when I shade this thing, I need to shade 1 out of every 2. Now I could just say, look, I'm going to shade this 1 out of 2. 1 out of the 2, 1 out of the 2, 1 out of the 2. Alright? But that again will get a little sloppy if we continue in that pattern. So I can just look at this in terms of rows. If I shade this row, then I would not shade this one. If I shade this row, that's 1 out of 2, so that can match with that one. And then I could shade this one, which matches this. Or you could shade this one, which matches that one. And finally, this row matches that one. So I've got 5 shaded rows and 5 not shaded rows, which really gives me a ratio of 1 to 2. 1 row shaded for every 2 rows. So the decimal value on this would be 0.5. Now if you wanted to show it as 0.50, that's okay, because we have 100 parts and 50 of them are shaded. So that'd be 50 hundredths. And then as a percent, this would be 50%. Alright, this next one, B, so I'm going to shade 1 out of every 4 rows. So I could shade this one, and then that would be kind of comparable with these 4 rows, right? And then if I shaded this row, then it kind of takes care of these 4 rows. But then I have an uneven amount right here. So then I've got to look at this and shade and see if I shade these 2. Then it kind of takes care of these 4 parts. So if I shade these 2, then it also takes care of these 4 parts. Then I've only got 4 parts remaining, so I could shade this part, which again would be compared with these 4 parts. So as a decimal, how many did I shade? I shaded, I can count them, 10, 20, 2, 4, 5. I shaded 25 parts out of 100. So as a decimal, this would be 25 hundredths. So the percent would be 25%. And so some of you did know to just shade 25 parts of this, which would have been okay on that. Yep. All right, so F, this one wants us to shade 1 out of every 8 parts. So if we can look at this and identify 8 of the parts, particularly for me, I'm going to identify 8 of these rows. Okay. Then I know that I need to shade in 1 out of the 8. So there's my shading, 1 out of the 8. Well, then I've got 20 parts left, and I can identify 16 of those. Now I'm looking at these horizontally, and if I shaded 1 out of those 8, there's those 2. But then I've got 4, so as it turns out, I'm going to need to go into these last 4 parts and cut them in half. So now that I can compare 8 of those parts. Well, now that I do have 8 parts, I would only shade in 1 of these. So here we go. There's shading one of those 8 parts. Now those are halves though, because I cut them in half. So this, as it turns out, ends up being, I had 12 hundredths, but then that half as well. So this would be 0.125, which as a percent is 12.5%. All right, this next one, again, we can look at this as 1/3. Now, some of us know the decimal of that, right? It's just 0.33, but it repeats. So the percent also would be 33.3%. Okay, so I need to shade in 33 of these, is what that means. So let's get 33. There's 30. And then 3. Then I've got to shade 1/3 of one of these. So if I go in and split it up into thirds, I would shade in one of these thirds. Like this. And that would be the grid. Alright, so number 10, this is how we're going to be changing fractions to decimals, alright? So we're going to use long division on these, and A was done for you guys already. Now here's why we're using long division at all anyways, is because this this fraction line really represents division. So this is really 1 divided by 4. So long division on this would be 1 divided by 4. Now 4 doesn't go into 1, so we got to treat this as a 10. And 4 will go into 10 twice. So 2 times 4 is 8, and I'll subtract. 10 minus 8 is 2. 4 doesn't go into 2, but if I tack on another 0 there, I can make that 20. 4 does go into 20 5 times. 5 times 4 is 20. Bam. Then I've got 0 remaining. And my decimal value on this, 0.25. Alright, so that's the decimal. So, and we can take that decimal, 0.25. And if we want the percent, all we're going to do is move that decimal 2 times to the right. Okay, so this makes that 25%. So to change decimals to percents, always just move the decimal 2 times to the right. And you'll have your percent. So what that means is if we want to change a percent to a decimal, we would move the decimal back 2 times to the left. But we have to keep those in order so we know the difference. So on this one, this again would be 1 divided by 5. So I've got 1 divided by 5. Now 5 again does not go into 1, but it will go into 10 twice. 2 times 5 is 10. Bam, I got 0 remaining. So this is my decimal right here. And again, if I wanted to change this decimal into a percent, I would move the decimal 2 times to the right, 1, 2. If there are any empty place values, I just fill that in with a 0. So this ends up being 20%. Alright, F, we got 1 divided by 8. So again, we can rewrite it if it helps us to see that better. And this is 1 divided by 8. Once again, 8 does not go into 1. So we'll make this a 10. And 8 will go into 10 once. 1 times 8 is 8, which gives me 2. 8 doesn't go into 2, but if we drop a 0, make that 20. 8 will go into 20 twice. 2 times 8 is 16. So I'm left with 4 right here. Again, 8 doesn't go into 4, but it will go into 40. And it will go into 40 5 times. 5 times 8 is 40. Bam, 0 remaining. There is our decimal. So with this decimal, 0.125, and we've seen this one already today, is if we move the decimal 2 times to the right, 1, 2, it's in between the 2 and the 5, which is okay. It just gives us a decimal value in the percent, which can happen sometimes. So 12.5%. Alright, 1/9. So this one, once again, could be written as 1 divided by 9. So in long division, it's 1 divided by 9. And 9 does not go into 1, but it will go into 10 once. So we'll subtract 9 on that, and that's a 1 as well. So notice this number matches, the one that we got matches the number we started with, which means that if we continue this process, we're just going to end up with the same number every time. See that? So what that means is that the 1 repeats. And that's our decimal. So how do we write this as a percent? Well, we could write the decimal, 0.11111, and then that repeats, just to show us that we can move this thing twice, 2 times, which would then be 11.111 repeating. Of course, you could show all the ones repeat, and then this is a percent. There we go. So we'll shade this in, this fraction, and then we'll write the decimal and the percent as well. So another way we can look at this is if I can get this to be, because I've got 100 parts in this grid, then it will tell me how many to shade in. Well, this is just like a proportion, 100 times 1 divided by 10, bam, 10. So what that means is I can just immediately shade in 10 of these blocks, or squares, or whatever the heck you want to call them. And there I go. I'm done with the grid, but of course we still need the decimal. So the decimal on these would be 1 divided by 10, which would give you 0.1, which as a percent is 10%. Would move that decimal 2 times to the right, 10 percentages. Now let's try that strategy with D. So this one, again, we want it out of hundreds so that we can see what we would need, how many of these boxes we need to shade in. So I got 100 times 1 divided by 5, 20. So I'm going to shade in 20 of these boxes. Well, each row is 10. So there's 10 right here. But I need 20, so I'm going to shade in these 10 as well. 20. 20 box, which as a decimal, another way we can look at this is that you'd have 0, then you'd have tenths, and then hundredths. That's 20 hundredths. So it'd be 20 hundredths. Now, you don't need that 0 to the right, but you can if you want. All right, so the percent, again, we're just going to move that decimal 2 times to the right. 1, 2, bam, 20%. Which is kind of shown in the hundredths part, right? 20 hundredths would be 20%. E is very nice because it's already shown in the hundredths. So we'll just shade in 1 out of these 100 parts. So the decimal, again, we're looking at hundredths position, 0. And the hundredths, you'd have 1. No tenths. Bam. So again, the decimal, the percent will move 2 times to the right, and we get, well, 1%. All right, what about 1/9? Well, this one is a little bit different because you're going to get a decimal if we figure out something over 100. So what we can do is we can fill in 1 out of every 9. So that would be, for example, if I filled in this row, then it would take care of those 9 rows. Then if I filled in this 1, it would take care of that 1 right here. So let me show this a little bit different. So of this rectangle, I've got 9 rows, and I've only filled in 1. 1 out of 9 rows. Well, then I split this last, what I have remaining, up right here. And I had 1, I filled in 1 out of those 9. But then I've got 1 more square left, and I've got to fill in 1/9 of it. So that's what I can do. I would fill in 1/9 of it, which is something, well, that's kind of big. Let's fill it in like these. Very small. Alright, so I filled in 1/9 of 1 out of these 9 rows, 1 out of these 9 squares, and then 1/9 of this last square. Alright. So yeah, one of the squares was filled in only partially, 1/9. Now that doesn't have to make a lot of sense, but we should be able to find the decimal on these. So that would be 1 divided by old 9er, which should give us 0.1 repeating. So 0.1 repeat That's not a T. The percent would be 11.1, repeating percent. So let's look at these. So we got 0.1 repeating, that's 11.1%, which means I need to fill in 11 of these boxes. So there's 10 of these, right? And then I need one more to make 11. But then I need 0.1 repeating, which is about a ninth. About like that. See, now that shading is very pretty. Right there. Now that assumes that we started with either the percent or the decimal. So you have to be comfortable finding the decimal or the percent. You may have to do that first in some cases. Long division. So to show this is 1 divided by 10, right? So in long division, we got 1 divided by 10. 10 does not go into 1, but it will go into 10. So we got the decimal and the 0 right count. So 10 will go into 10 exactly one time. 1 times 10 is 10. Subtract, bam, 0. Nailed it. So on these, we got 1 divided by 100. So we're going to do it 1 divided by 100. Now again, 100 won't go into 1, but it won't go into 10 either. So we got to make this 100, which it will go into 100 once. 1 times 100 is 100. So when we subtract these, we get 0 remaining. Bam, there's our answer. Now we got this 1 divided by 3. Some of you guys already know what this is. 1 divided by 3. So I got 1 divided by 3. 3 does not go into 1, so we're going to have to make that a 10 with the decimal. 3 goes into 10 3 times. 3 times 3 is 9er. And we get the 1. Now we've already talked about this, but see how I got this 1 right here? And we had started with that 1? That means that if we continue this process, right, I'll get another 10. It'll just go into it 3 times, 9. It's just going to continue to repeat itself. So the actual answer is 0.3 repeating. Yeah, there's those percentages on those. I forgot them.